The NASA Space Shuttle Program was one of the most ambitious and iconic endeavors in space exploration, running from 1981 to 2011. The program marked a new era in human spaceflight, with the goal of creating reusable spacecraft that could ferry astronauts and cargo to and from orbit. Unlike the earlier Mercury, Gemini, and Apollo missions, which were one-off missions, the Space Shuttle was designed to be flown multiple times, making space travel more routine and affordable. The development of the Space Shuttle began in the late 1960s, as NASA looked for ways to reduce the cost of space missions. The Apollo program had demonstrated America's capability to land humans on the Moon, but the high costs associated with each mission made it unsustainable for regular flights. NASA envisioned a reusable spacecraft that could be launched frequently, carry large payloads, and return to Earth for refurbishment and reuse. This vision led to the creation of the Space Transportation System, STS, commonly known as the Space Shuttle. The Space Shuttle was a unique spacecraft, consisting of three main components: the orbiter, the external fuel tank, and the solid rocket boosters, SRBs. The orbiter was the part of the shuttle that housed the crew and cargo, and it had wings that allowed it to glide back to Earth like an airplane. The external fuel tank supplied fuel to the shuttle's main engines during launch, while the SRBs provided additional thrust to propel the shuttle into space. After launch, the SRBs would detach and fall into the ocean to be recovered and reused, while the external fuel tank would burn up in the atmosphere. The first space shuttle, Columbia, launched on April 12, 1981, with astronauts John Young and Robert Crippen aboard. This mission, designated STS-1, was a test flight to demonstrate the shuttle's capabilities. Despite some minor technical issues, the flight was a success, proving that the shuttle could safely launch, operate in space, and return to Earth. The orbiter re-entered the atmosphere and glided to a landing on a runway at Edwards Air Force Base in California, marking the first time a spacecraft had returned to Earth in this manner. Over the course of the program, NASA built 5 space shuttle orbiters: Columbia, Challenger, Discovery, Atlantis, and Endeavour. Each orbiter was designed to be reusable, with the goal of reducing the cost per flight. The Space Shuttle's versatility allowed it to carry a wide range of payloads, including satellites, scientific instruments, and components for space stations. The shuttle also served as a platform for conducting experiments in microgravity, advancing scientific knowledge in fields such as biology, physics, and materials science. One of the primary objectives of the Space Shuttle program was to enable the construction and maintenance of space stations. The shuttle played a key role in the assembly of the International Space Station, ISS, delivering key components to orbit and helping to piece together the modular station. Shuttle missions carried astronauts and equipment to the ISS, making it a central hub for international cooperation in space. The shuttle's large cargo bay made it ideal for transporting massive station components, such as solar panels and laboratory modules. In addition to supporting space station construction, the shuttle was used for satellite deployment and repair. One of the most famous shuttle missions was the deployment and subsequent servicing of the Hubble Space Telescope. Launched in 1990 aboard the Shuttle Discovery, STS-31, the Hubble telescope provided unprecedented views of the universe, but its initial performance was hindered by a flaw in its primary mirror. In 1993, the shuttle Endeavour, STS-61, carried astronauts to repair the telescope in space, installing corrective optics that restored Hubble's full capability. This mission was one of several shuttle flights that extended the life and capabilities of the Hubble telescope. The Space Shuttle program was not without its tragedies. On January 28, 1986, the shuttle Challenger, STS-51L, broke apart just 73 seconds after launch, killing all 7 astronauts aboard, including Krista McAuliffe, a teacher who had been selected as part of the Teacher in Space program. The disaster was caused by the failure of an O-ring seal on one of the solid rocket boosters, which allowed hot gases to escape and damage the external fuel tank. The loss of Challenger was a devastating blow to NASA and the space community, leading to a 2-year hiatus in shuttle flights while the agency worked to improve safety. The shuttle returned to flight in 1988 with the launch of Discovery, STS-26. NASA had implemented several changes to the shuttle's design and operational procedures to enhance safety. Despite these improvements, tragedy struck again on February 1, 2003, when the shuttle Columbia, STS-107, disintegrated during re-entry, killing all 7 crew members. The disaster was caused by damage to Columbia's thermal protection system, which had been struck by a piece of foam insulation during launch. The loss of Columbia once again led to a suspension of shuttle flights and a re-evaluation of the program. Despite the risks, the shuttle remained a crucial part of NASA's space exploration efforts. Following the Columbia accident, NASA focused on completing the construction of the ISS and preparing for the transition to a new generation of spacecraft. The shuttle was instrumental in delivering the final components of the ISS, and its ability to transport large payloads and perform complex construction tasks made it essential to the station's completion. One of the key advantages of the Space Shuttle was its ability to return cargo from space. Unlike previous spacecraft, which burned up in the atmosphere or landed in the ocean, the shuttle could bring scientific instruments, satellites, and even experiments back to Earth for analysis and refurbishment. This capability was particularly valuable for programs like the Spacelab missions, which allowed scientists to conduct experiments in space and retrieve the results for further study. The shuttle also played a role in advancing international cooperation in space. The Shuttle Mir program, which began in 1995, involved a series of missions where American space shuttles docked with the Russian Mir space station. This program helped pave the way for the ISS and strengthened cooperation between NASA and the Russian Space Agency. Shuttle missions to Mir demonstrated the shuttle's versatility and provided valuable experience in long-duration spaceflight and international collaboration. In total, the Space Shuttle Program conducted 135 missions over its 30-year history. These missions included everything from deploying interplanetary probes to carrying out classified military operations. The shuttle's versatility made it one of the most adaptable spacecraft ever built, capable of performing a wide range of tasks in space. However, the program was also costly, with each shuttle flight costing hundreds of millions of dollars, despite the initial promise of reducing the cost of space travel. One of the significant scientific achievements of the shuttle era was the deployment of interplanetary spacecraft. The shuttle launched several important missions to explore other planets, including the Galileo probe to Jupiter and the Magellan mission to Venus. The shuttle's ability to carry large payloads and deploy them into the correct orbits made it a valuable tool for advancing planetary science. The end of the Space Shuttle Program was announced in 2004, following President George W. Bush's vision for space exploration, which called for the retirement of the shuttle and the development of new spacecraft capable of carrying humans beyond low Earth orbit. The last shuttle mission, STS-135, flew in July 2011, with the orbiter Atlantis carrying supplies to the ISS. The conclusion of the program marked the end of an era in human spaceflight, as NASA shifted its focus to developing the Orion spacecraft and commercial partnerships to transport astronauts to space. The Space Shuttle Program left a profound legacy in space exploration. It advanced our understanding of the challenges of living and working in space, and it demonstrated the value of reusable spacecraft. The shuttle's contributions to scientific research, space station construction, satellite deployment, and international cooperation were invaluable. While the shuttle did not achieve the cost reductions initially envisioned, its achievements far outweighed its shortcomings, shaping the future of human space exploration. The International Space Station, ISS, perhaps the shuttle's greatest legacy, continues to operate today, serving as a platform for international collaboration and scientific research. The ISS would not have been possible without the shuttle's ability to transport large modules and perform complex assembly tasks in orbit. The shuttle's role in the station's construction cemented its place in history as a vital tool for advancing human spaceflight. The Space Shuttle Program also fostered a new generation of astronauts, many of whom went on to contribute to future space exploration efforts. The experience gained during shuttle missions, particularly in areas like extravehicular activity, EVA, orbital construction, and long-duration spaceflight, provided valuable insights that continue to inform modern space missions. Astronauts who flew on the shuttle have become leaders in space exploration, contributing to programs like NASA's Artemis initiative to return humans to the Moon. Despite its 2 tragedies, the Space Shuttle Program is remembered as one of NASA's most significant achievements. It demonstrated the potential of reusable spacecraft and paved the way for the next generation of space exploration vehicles. The program's contributions to science, technology, and international cooperation are still felt today, as the space community looks to the future of exploration beyond Earth. As NASA moves forward with new programs like Artemis and Gateway, the lessons learned from the shuttle era will continue to guide the development of future spacecraft and missions. The shuttle proved that humans could live, work, and thrive in space for extended periods, and it laid the groundwork for the next phase of exploration, returning to the Moon and eventually sending humans to Mars. In the end, the Space Shuttle Program represented both the triumphs and challenges of space exploration. Its successes in advancing science and technology were tempered by the risks and costs associated with human spaceflight. Yet, the program's legacy lives on in the advancements it enabled and the knowledge it provided. As humanity continues to reach for the stars, the spirit of the Space Shuttle Program will remain a guiding force in our journey into the cosmos.